All right, fundamental theorem of calculus, really, really important. Suddenly, we don't have a plain integral. We have an integral with limits. Has a lower limit and an upper limit. And the integral from a to b of f of x dx is the integral evaluated at b minus the integral evaluated at a. So you're going to find the integral, you're going to do your integration, and then you're going to plug in this number, you're going to plug in this number, subtract b minus a, and that will give you the integral at a particular limit area. Okay? Fundamental theorem of calculus. If we had all the time in the world, we would do a lot more investigation of that and how that's arrived and that sort of thing. We just don't have time. So we're just going with it. All right, I wanted you to see the difference. This is what we've done so far. We've had, say, the integral of 4t cubed. We rewrote it. We said that was 4 times the integral of t cubed dt. And then we did the integral, which is t to the 4th over 4. Those canceled out, and we had t to the 4th plus c. Remember, we always had to have that plus c because it could be different things that would give us that. Well, now we're going to have some that are different. So I'm going to do that same problem with limits. From 1 to 2, I want the integral of 4t cubed dt. I've already done the work to get the integral. It's t to the 4th. But now I write this little bracket thing over here and put the lower limit on the bottom, upper limit up here. So this is t to the 4th evaluated from 1 to 2. And what the fundamental theorem said was I'm going to put 2 into that, so 2 to the 4th, minus, put 1 in there, 1 to the 4th, and you'll get a value. You'll get a number, 15. There's no plus c, there's no letters, you get a value. Okay? So if you have limits out here, you'll get a number. Now, let's see how to do that on the calculator. Some of these I'm going to ask you to work out and show all the work. Some of them you will be able to use the calculator, so we need to know how to do that. So we're going to work that same problem, this one right here, on the calculator. Everybody got a calculator? Okay, you know, with numerical derivatives, we did Math 8. Now it's Math 9. So choose Math 9. And you're going to put in the function first, like we did in Math 8. So you'll put in 4x cubed, comma, x, it's function, comma, variable, comma, lower limit, so it'll be a comma 1, comma 2. Function, x, lower, upper. Try that and hit enter and see if you get 15. Did we get 15? Okay. That comes in really handy if it's an integral that's really ugly to do. If you're doing it at particular limits, you just throw it in the calculator.
I missed 4x cubed.
Comma, x. You forgot the x. And then comma 1, comma 2. Did that get it? You didn't? Okay. Math 9, and then put in 4x cubed, comma, x, comma 1, comma 2. Krista, did you get it? Can you? Oh, you, okay. All right. Anybody else? And you did get it, Jason? Okay. All right. So let's look at the problems. Let's make sure we could do them by hand, and then some of them we'll do with the calculator. Okay? All right. Some of these easy ones, it's not a problem. The integral from 1 to 5 of 3 dx. Well, the integral of 3 is 3x. So you've got 3x evaluated from 1 to 5. That means we're going to plug in 5 and we're going to plug in 1, and we're going to subtract them. So 3 times 5 is 15, minus 3 times 1, you should get 12. That one's easy. These are not bad. Integral from 2 to 4 of 2x plus 7 dx. The integral of 2x is 2x squared over 2 plus 7x, and that's evaluated 4 and 2. So I have to plug in 4 into this thing. So that's 4 squared plus 7 times 4 minus, and here's where I'd caution you. You're subtracting that whole bunch of stuff on the right. Put it in brackets so that you're going to remember to subtract all those pieces. Minus 2 squared plus 7 times 2. Do your little arithmetic and your algebra, whatever it takes. You have 16 plus 28 minus 18. So you end up with 26. This is where you can get in trouble doing these. And because these are not going to be multiple choice, you got to show the work on some of this. You might get the integral right, but just do the arithmetic wrong. You're going to get partial credit for getting the integral, but you won't get full credit if you don't get 26. So you need to be careful. Here's where, if I'm telling you you have to show the work, you can check yourself on the calculator. Make sure you get the right answer with the correct work. Okay? All right. Number 3. Integral from 0 to 1, 7x squared minus 8x plus 3 dx. You have 3 pieces. We're going to take the integral of those 3 pieces. We end up with 7x cubed over 3 minus 8x squared over 2 plus 3x. So the integration there is pretty easy. We're going to evaluate it 1 and 0. Plug in 1 in the first part. You get 7/3 minus 4 plus 3. And then it's minus. Well, when you plug in 0 in all that, that just goes to 0. Okay? So combine these 3 things, and you get 4/3. The answers in Math Lab, they want it to be in fractions, so keep that in mind. Okay. Questions? Anybody? We are so not awake. All right. Now you get one of these. You have to use that U-substitution to actually get the integral. From 0 to 12 of the square root of 3x. Okay? So, if we let u be 3x, du is 3 dx. Do we have a 3 up here outside the radical? No. So we've got to divide by that 3. So we have 1/3 du equals dx. And now we match. Okay? Make sure you match if you're doing the U substitution. So when you rewrite the problem, you have 1/3 the integral from 0 to 12 of u to the 1/2. What's the integral of u to the 1/2? U to the 3/2 over 3/2. So we have 1/3 times u to the 3/2 over 3/2. What happens to that 3/2 on the bottom? Flips and multiplies up here. So I have 1/3 times 2/3 u to the 3/2 evaluated 0 to 12. I have 2/9. That came from multiplying here. That became that. And then I substituted back in what u was. It was 3x to the 3/2. So now I've got to plug in 12 and I've got to plug in 0. If I plug in 12, I get 36 to the 3 halves, and then minus 0. Can you do 36 to the 3 halves without using your calculator? We should be able to do that at this point. If not, you can do it on the calculator, but you take the square root of 36, that's 6. 6 cubed, you might not know that, but it's 216. But if not, you can do 3 halves on your calculator, and you get 48. Okay? Try that one on your calculator, Math 9, just to make sure we get 48. Remember, the original was way up here. So you're going to have Math 9, square root of 3x, close that parentheses after the square root, comma x, comma 0, comma 12. We should get 48. We need to practice enough so that you're able to do it on the calculator and get 48. Be sure you close the parentheses after 48. I mean after 3x, whatever we had in there, 3x. Everybody get it? We're good? Did you guys get it back there? Okay. All right. Number 5. Again, a U-substitution. If you're doing these on Math Lab, what are you going to do? Math 9. Yeah, you're going to do that. On the test, there will be some that I will say you have to do by hand. So it's worthwhile to go through that. But if you're sitting there at the computer, I know you're going to be doing that. Okay. So on this one, we would let u be 4x minus 5. Du would be 4dx, which we have here. Okay, so we have that matched. So we're going to have 1 over u squared, or u to the negative 2. The integral of u to the negative 2 is negative u to the negative 1. Because it was u to the negative 1 divided by negative 1. And then you plug back in and evaluate 5 and 4. And then it's a lot of arithmetic. We're going to plug in 5. We're going to plug in 4. And I think that one, they must expect you to be doing it with your calculator or something, because I think the answer is a decimal. So let's try that one on the calculator and make sure we get 0.0242. The original problem was this. Make sure you put it in correctly, the integral, and you're going to have 4 divided by parentheses 4x minus 5, close parentheses, squared. I think that's going to get it. Can't see it in my head. Comma x, comma 4, comma 5. Did that work? Anybody? Scoot it down. Mm-hmm. Like there? Okay. Did anybody get it? Doing it on the calculator? 0.0242? Okay. Holly, did you get what you needed out of that?
Yes.
Okay. Okay. 0.0242. Did you get it? Okay. All right. Number 6. Try it on your calculator and see what you get. because this one's expecting a fraction. But let's see if we can convert it from a decimal. So put this in as the function, x to the 7th, parentheses, 1 plus x to the 8th, close. So it needs to look like that. You'll actually have something like, somehow I had 3 of these. That's a lot of parentheses. Let's hope we get it. And whatever you get, convert it to a fraction at the end. And let's see. That's what we're shooting for, 255 over 64. Did you get that? Did I get it? Okay. You have to be careful when you have that many things going on and you're putting it in the calculator. Okay? Mm-hmm. 0.0242. Got it? Okay. All right. Here is the work for that one if you were doing it by hand. It is a U-substitution. You'd let that be U. There's your du. You don't have an 8. You divide by the 8, and then you match. And you would have to do all of that to get those fractions. It does work fine doing it by hand. You do need to know how to do that. But I know you're not going to do it on the calculator, on the homework. Okay. Okay. Try number 7 by hand. Let's try that and make sure we could do that one by hand. We're going to do a U-substitution. Okay. What's going to be your U? The thing in the radical. So do that one. I want you to work it all the way through and come up with a fractional answer without doing it on the calculator. I mean, you could check yourself, but try to do this one by hand. This might be one like you'd have to do on the test by hand. Okay, let's see. You should have had U to be that. Du gets that, and so you notice that everything's taken care of. And then when you substitute to rewrite, you have U to the 1/2 du. The integral of U to the 1/2 is U to the 3/2 over 3/2, which becomes 2/3 U to the 3/2. And then it's a matter of evaluating that after you plug back in 1 and 0. What's going to happen to the 0 part? Just goes away in this case. So we actually are plugging in 1, and so we end up with 1 to the 5th is 1 plus 3 is 4. 4 to the 3/2 times 2/3, and you get 16/3. Questions? Mm-hmm. How far? Good. Okay? All right, the last two questions, number 8 and number 9, talk about finding the area between the curve and the x-axis. Okay, what does this thing look like? If you put it in the calculator, what does 49 minus x squared look like? What shape is it? Parabola. And it's upside down. So it's doing this. You know, we have this. And it says it wants to know the area from -7 to 7. So what it's asking you to do is figure out the area inside here. And if we had the time to really discover and look at some things, we would learn that you can find the area under a curve by using integration. What you're doing is taking the sum of all these little areas of some rectangles, and you're going to infinity with that. There's a big proof on that. What you need to know at this point for today is that you can do this by integration. So what you're doing is integrating this function from -7 to 7, and it's going to give you that area. Okay? So if you write the integral from -7 to 7 of that, we have to do the integration. 49x minus x cubed over 3, evaluated from 7, well, from -7 to 7. This one we don't have a 0, so we got to do all the plugging in. All the plugging in. So I put in 7 here, I put in -7 here, and you end up with 457.3. Could you do that on a Math 9? You could. I think actually for this one it must want decimal, is why I did that, and I don't know why it just decides periodically to do that, but it does. Okay, number 9 is a little bit different. It gives you a picture, and it's talking about finding the total area of the shaded regions. How many regions are there if you're looking at your page? Well, count the parabola part as 1. 3. You have a little piece underneath on the left, you have the big parabola, and you have a little piece on the right if you're looking at your problems. Okay? So we have 3 different little things to do. So here's our picture. It's like your picture on your paper. And it gives you that that's the function, 100 minus x squared. Okay? If it didn't give you the picture, you could put that in the calculator and get that picture, but it did. So, first of all, let's get this area. That's the integral from -10 to 10 of 100 minus x squared dx. Now, where did I get the -10 and the 10? Count on your graph. Where that parabola hits right there, that should be -10 and 10. When you integrate, you get 100x minus x cubed over 3. You need to evaluate it at 10 and -10. So I'm plugging in +10, +10, -10, -10 there. It's a lot of fraction work, and you should get 1333 1/3. Is that part okay? Everybody all right with that? We're just taking the area under that parabola from negative 10 to 10. What if you did that on the Math 9? What would you get? Try it. 100 minus x squared is your function, and your comma x, comma negative 10, comma 10. Let's see what you get. We get 1333.333. Did you get something like that? Okay, so you could verify yourself there. You can't get the whole answer at one point on the calculator. You got to do this in pieces. All right, now for that little piece on the left, this piece here, the integration limits are from negative 11 to negative 10. Negative 11 to negative 10. And it's underneath the x-axis, so it's going to be negative function. So we have negative of this thing from negative 11 to negative 10. And we get 10 1/3. If you do it on the calculator, you should get 10.333, something like that. And the other side is still negative because it's under the x-axis, but our integration limits are from 10 to 11, and we'll still get 10 1/3. What do we do with those three things? Add them. That'll give us the total area of that yellow thing. These three things added give us 1354. And that's the way you have to work that problem. Questions on that one? Add them up, get 1354. You can use your calculator to help you, but you need to know how to do the fraction work, because there will be some that you're forced to do that way. Not necessarily on the homework, but if you only use the calculator, you won't be as prepared.